Right, let's look at the theory of surds. Whenever we have a square root where the identical square root is being multiplied, the theory of surds say that the square root of 2 times the square root of 2 can be written as the square root of 2 times 2. The square root of 2 is quite complicated. We don't know it. It's infinite number of decimal places. We'd have to use a calculator. So we wouldn't be able to do this without quite some complicated maths. Okay? But we do know that 2 times 2 is 4. So we can, what surd says is we can reorganize this into 2 times 2, which is 4, and the square root of 4 we know is really easy, because 2 times 2 gives us 4. So the square root of 4 is 2. So these two quite complicated terms, which would have been something like 1.41 times 1.41 that would take us quite a long time to do. Using this theory of surds, changing it into 2 times 2, which is 4, and taking the square root of the whole of 4, giving us 2. And you can actually test this at home in your calculators. Write down the square root of 2, then write down the square root of 2 again, multiply the two together using your calculator, and you'll get the answer 2. Right, so if I have then the square root of a times the square root of a, I can simplify that to the square root of a times a, which is the square root of a times a is a squared. The square root of anything squared is exactly the same as that number, so it's going to give me back a, where I was in the beginning. The square root of 2x times 2x can be written as the square root of 4x squared. But the square root of 4 is 2, and the square root of x squared is x. So you see, I get back to what I had in my original question. Square root of 3y times the square root of 3y is the same as the square root of 3y times 3y, the square root of the whole thing. 3 times 3 is 9. Y times y is y squared. If we take the square root of 9, we get 3. The square root of y squared, we get y. So we get back to what we had in the original question. So that's the basics of surds, and what can we use them for? Well, look here. If we have the square root of 4x times the square root of x, we don't know what the square root of x is, but we could reorganize this. We know the square root of 4, that's easy, but we don't know the square root of x. What we can say here is the same as the square root of 4x times x. That's the same as the square root of 4x times x is x squared. The square root of 4 is 2, and the square root of x squared is x. So this middle step is very important here to get that correct. Same thing here. Root 9 times root x gives us the square root of 9x times x, which is the same as the square root of 9x squared. The square root of 9 is 3, and the square root of x squared is x. And it doesn't matter which letter you've got here. Square root of 25x times root 25x is the same as the square root of 25x multiplied by x, which is the same as the square root of 25x squared, which is the square root of 25 is 5, and the square root of x squared is x. So if we had something here like, let's say that we had the square root of 3x times 3x times 3x. And we know the square root of 3x times 3x, we know it's going to be 3x. The square root of 16a times 16a is going to be, the square root of 16 is 4. Square root of 16 again is 4 here, times a. So it's going to be 16a. So that's the theory of square roots, and it actually works exactly the same whether it's cubed roots as well. Okay? That's the theory of surds.